Okay, good afternoon, pilot teachers and students, and good afternoon, model class.
Good afternoon, Mr. Sarah.
All right, thank you very much. You may sit down. All right. We will be only looking at our topic for now will be on energy. That is what we'll be looking at, right? If you can know from the last lessons we went through and had a look at the different forms of energies and the secondary. But looking at the rate at which this energy can be converted. Now, there are some machines which are not 100% efficient. Okay, efficiency meaning that the rate at which one energy form or one energy has to be transferred to another. Likewise, our human body cannot convert all the energy that we have in our body. For example, if we have to eat the food, okay, not every one of these will be changed into other forms. Let's say heat, or can be kinetic, or the amount of energy that we use to do work. Okay, but others may be lost. Now, they are not actually lost, but it can be to other forms. So energy conversion can also depend on the size, or let's say the efficiency of the machine. Right? If the machine is 100% efficient, probably the amount of energy conversion from one form to the next would be K. So having to look at the definition, which is the energy. Right? Energy is the capacity of an object to do work. Now, looking at other forms of energy, there are different forms. We have seen the major ones, which are either chemical, mechanical, or electrical. But there are some forms which comes under these three types, and which may include potential energy as well as kinetic. Those are some forms of energy which may come under the three main types as mentioned. Right? If we have to move on, right, the work done has to tell us how much energy has been converted from one form to the next, or let's say from one form to another form. None of this energy can be lost. Okay? It is only transferred to one form, or from one form to the next. And if you are looking at the creation of energy, it can neither be created as well. So putting these two together, we can come up with a law which says that energy can neither be created or destroyed, but it is converted from one form to another. All right, if we can look at the next. All right, the thermal energy of the heat is simply the movement of the energy, or movement energy of the molecules. Especially when you are heating up an object, there are the molecules which will be moving. That will cause the heat. Okay. Right, anything that moves has this particular kind of energy, which is known as kinetic energy. Okay, movement energy is simply the kinetic energy, right? That is when anything is moving, it will possess this form of energy, right? Moving on to another kind of mechanical energy would be stored, and we simply call this form as potential energy. All right, looking at this, potential energy can also come under various types. One is gravitational potential energy. For example, if you have to take one or something to a certain height and then let it fall, right, it has this gravitational potential energy. And then others can be stored. For example, in a battery, you can have chemical potential energy. And then you have also the potential energy found in a string, or rather a spring or rubber band, and that is known as elastic potential energy. All right. Okay, that is the first one, or the first type. Okay. We'll now move on. Okay, many examples of this elastic energy can be seen in either coil or spring coil, let's say an elastic bow, or it can be from a catapult, or either we can find it in a rubber band. All right, the air also has some kind of elastic properties. For example, if you have to use, or let's say use a pump you push against the handle of the pump and then you let it go, you'll find that the pump will have to move or the handle will have to move. Why? Because the air has some kind of elastic potential energy. Right, I'm quite sure you may have finished. All right, that is basically the chemical stored energy, or we can say chemical potential energy in foods. Right, if you eat from foods, you get this stored energy, and these fuels are also the fuel that being used, especially in cars and also aeroplane, come from chemicals. So we can say that they have some kind of chemical stored energy there. All right, as mentioned, if you are trying to eat those, or you get those food from the energy from the food. But I said, not much of this can be used, especially when you are running. Not all of that will be used on kinetic energy, right? Some can be used in heat or other forms as well. Okay. From this, I will give you activity questions to, and basically for that nuclear energy which is stored in the center of the nucleus. All right. Okay, if somebody has to do a work, all right, for the first question, okay, what is the chemical energy from the food that will give him the strength to live that? Okay, that is for question number one. The work done is about 100 joule of energy. Okay, what would be the chemical energy from the food to give him the strength? Okay, that is question number one. Okay, if I have to give you question number two. Moving on to question number 2 is, right, if a diver has to use about 6,000 joule of his chemical energy to climb into the top of the stair or the platform, and then if he or she is trying to do some kind of gymnastic move, okay, what is the tensile energy at the top? All right, here will be the last question. That is question number 2, and then if I have to give you question 3, okay, that is the 80 joule of his chemical energy from food. Okay, what is the kinetic energy of the person? right, I will give you some time quickly to go through your questions. There are only 3 questions. Please do answer those questions, and then we'll have a look at or discuss those answers to the questions. There's no formula being used. Yeah, we can study one of those. Basically, where did we stop? Okay. There's no formula that you can use, but using the conversion of energy and all this, you can assume only that probably part of that was formed or moved to transformed. Okay, the first energy was 18, so that means the same amount will be, changed to. Okay, there is nothing. But if it is, you are taking something from here, let's say this one, probably you do the same amount of work to get this one up here. And if you leave it here, it's going to have the same amount of energy that you did in moving it up here. So that means when it falls, it will have the same amount of energy. Okay, we will now go through and then discuss the answers to those activity questions. I will ask probably 3 volunteers to give us the answer to that question. All right, for question number 1. The work done by a man in lifting weights is 1000 joules. What is the chemical energy from the food to give him the strength? Okay, Alan Mark.
Food provides 100 joules of energy for him to lift the weights.
It will be?
100 joules of energy.
Okay. John, what do you think? Okay, John is also saying that the amount of energy will be 100 joule. Okay, that is quite correct. All right. That is for question number 1. If he has to take that 100 joule from that food, or if he is doing work, then probably 100 joules of energy was provided by the food that he ate. Okay. All right. Moving on to question 2 is a diver uses about 6,000 joule of chemical energy to climb to the top. Okay, Malcolm, you give us the answer to that question.
$6,000 joules of potential energy.
All right, if he has to do a work of about 6,000 joule, and when he is up there at top, probably he will have 6,000 joules of energy. That is correct. Now, just imagine if that person who has been at the top, and if he's falling down at the bottom of that platform, probably he will possess about 6,000 joules of kinetic energy, right? That is especially when he is falling down. But halfway, or let's say in the middle of that platform, if he is falling down, he'll have two. Okay, one would be about 3,000 joule of potential and 3,000 of kinetic energy. Okay. Okay, now moving on to the last question, that is the current. What is your answer to that question? Question number 3.
The kinetic energy of the person is 80 joules.
Right. That is 80 joule. That is quite correct, and he's right. So for question number 3 will be 80. If the chemical energy has to come from food, it will be the 80 joule of energy that will be used in running. All right. In our next lesson, we'll be looking at the efficiency of machines. It is not only in our body which can be efficient to produce the exact amount of energy that is taken. For example, we are not really saying that 80 joule be converted to kinetic energy, right? Some can be given in other forms. Probably 20 will be for heat, and then 60 for kinetic energy. So in our next lesson, when we study efficiency of the machines, you can look at how much of that energy can be, and that depends on the machine. If it is 100% efficient, probably in here all the chemical energy from which is about 80 joules will be converted to kinetic energy. But if it is not efficient, can probably may have 1% of that energy being, but all in all, energy can neither be created or destroyed, but it can be transformed. All right, that is the end of the lesson. Okay. Our key phrase will be, our keyword will be the energy. Okay, good afternoon, pilot teachers and students, and good afternoon, model class.
Good afternoon, Mr. Sarah.
All right, thank you very much. You may sit down.